Hello, everyone, and welcome to the AWS OnAir Data Dive. I'm your host, Jason Hunter, a Principal Solution Architect with DynamoDB. And this week, we're going to talk about actually DynamoDB and global tables and how you can use global tables to replicate copies of your data across numerous regions in order to have lower latency access to your data and in order to have resilience in case for any reason you want to move more of your traffic to one region than another one. And I'm here with two friends and coworkers, Jeff and Rob. Jeff, could you introduce yourself?
Hi, I'm Jeff Duffy, and I'm a product manager for Amazon DynamoDB.
And Rob?
Hey, everyone. I'm Rob McCauley, Specialist Solutions Architect for DynamoDB.
All right, so Rob and I tend to try to help customers understand how to make the most out of DynamoDB. And we talk with Jeff sometimes to say if we did this or that thing, customers would really love it. So we go to Jeff and say, like global tables would be really awesome. Could we do it? Then we get it. And then we get to do a show like this and talk about global tables. We've actually had global tables for 7 years now. At the end, we'll talk about the history of it and what version is best for you. Let's do a little level setting at the beginning, which is just if you're new to DynamoDB, let's make sure everyone knows what Dynamo's about. So maybe a softball question to you, Rob. DynamoDB is one of our purpose-built databases. So what's its purpose?
Yeah, DynamoDB, I love it. I think of it as the pure serverless database. It's just an API in the cloud. It's a fast, flexible, NoSQL database. So you can use it for new applications, for small applications. It's got unlimited scale and no servers to manage, which is probably my favorite part.
It looks like a magic endpoint. You write your data, you read your data. How can you said scale? Are we talking tens of thousands, hundreds, millions?
Yeah, they don't really publish an upper limit on how big a table could be. So it could be hundreds of terabytes or higher. I have one customer that's doing 1 million writes per second every day throughout the year. So and that's fine. The system works like that. So yeah, it definitely can scale up to really high levels.
I've been doing databases a long time, and every time I hear millions per second, I just think, imagine a real world situation where 1 million things get processed in 1 second in some rig. That's a crazy amount of speed. So it's differentiating features. You said serverless, scale, latency, right?
Those are good ones for developers. It's a NoSQL database, so there's no schema. What that means is if you wanted to extend your application and maybe add a new column, which we call attributes, you can go ahead and just write a new record with more data in it. You're not going to break a schema. You're not going to have to do a change to make a new schema change. So it's really nice for, when your application wants to add features. There's an easy path to have high velocity and to roll out features quickly with DynamoDB.
I remember a statistic went out recently that over 1 million customers are using DynamoDB. Do you have a favorite customer story, like the quintessential only with Dynamo story?
When my kids are playing games on their phones, some of them I know are powered by DynamoDB, so I always tell them that, and they kind of roll their eyes, but they keep playing.
Mine too. I do the same thing. I try to get teenage credit for all of that work you did on that game. It's only remembered because of the database I work on. And you're like, all right, Dad, whatever.
Yeah, that's how it goes.
Jeff, do you have any favorite customer story that gets you any credibility with anybody?
Credibility. Well, we'll talk about in a few minutes. I think the customer advantages that we're going to talk about from global tables, across a bunch of different industries, and I guess they're not as cool for my kids, talking about maybe financial or video conferencing as a game, but hey, they're still useful. So yeah.
I know. I keep trying to figure out what use case would make my kid be impressed, and I'll let you know if I ever find it. All right. So global tables then are an aspect of DynamoDB. It's a differentiating feature. Not a lot of databases do this because one of the interesting things is our global tables are active.
Yep.
Right. Can you reach at any time? Do you want to give us an overview of global tables, Jeff?
Yeah. So global tables are a feature of DynamoDB that lets you replicate the data from a DynamoDB table to multiple AWS regions. And as listeners might know, AWS groups our resources into geographic parts of the world that we call regions, and we have them all over the world. And what global tables lets you do is to take data that's in one region and replicate changes to that to one or more other regions in the world. And you can have more than one, right? We actually call it a multi-region, multi-active database because one of the nice features about global tables is that we don't have the concept of like a single leader, right? And so where other database solutions that allow you to replicate data geographically may have what they call an active passive scenario, where you can only make changes in one place, they get replicated somewhere else, but then you have to do some sort of failover if you want to change where you're writing your data. Global tables is multi-active, which means that anywhere that you're replicating your data, you can change that data, and those changes will be updated everywhere else that your data is being replicated.
Yeah, that takes some getting used to. We're always used to like, this is the primary, that's the replica, writes go here, and then there's a big failover scenario. And now you're going to take the writes in here, like take your pick, write to the region. Although, I mean, you have to be careful about that in some circumstances that we'll talk about later. But it is something that changes how you think. And I think, tell me if I'm wrong about this, but since I've done relational, this is NoSQL, this is item oriented, you tend to have the idea that this is a key that describes a thing. Am I right that it's a little easier to do active-active in a world where you're updating the thing and the thing replicates to the other side than in third normal form, where my thing is spread across numerous tables and I might update 4 tables and they replicate over piecemeal, meaning that I break my consistency?
Yeah, for sure. And it's not just, I guess, easier to design, but more importantly, it's much more performant when we can constrain the scope of what we're thinking about replicating to an item in a table, rather than, maybe 3 or 4 or 5 rows in a relational database that are all related to each other with, foreign keys or some other sort of referential integrity. And so one of the, as we talked about, sort of most important aspects of DynamoDB is our consistent performance at any scale, talking about how customers can run those millions of changes per second. That remains true with global tables. So global tables is designed to operate and replicate at DynamoDB scale. And that's one of the ways that we achieve that, is to kind of constrain the replication down to the item level.
Gotcha. So if I have an existing table with some data in it, can I make it a global table?
Absolutely. And it's very easy. One of our design goals and the tenets as a product manager that I think about every single day is to make global tables as easy to use as possible for customers. And so it's, if you have a table today that's a regional table in an AWS region, it's just a couple clicks in the console to go add one or even multiple other regions to replicate your data to. We do all the work behind the scenes without you having to think about how it works. And, just a few minutes later, your table is ready for you to make changes in any region where you replicate it. And it works both directions, right? So we want to make sure that we're flexible for what customers' needs are. And so should you need to copy to 3 or 4 regions, doesn't take very long to make that happen. And then should your needs change and maybe you don't need data in a region anymore, it's easy to delete it. And so flexibility is a major design goal for us for global tables.
So I could have 1 region, 2 regions. Maybe I delete this one, only have this one, kind of move my data seamlessly. All right, Rob, this sounds like a challenge. Can you prove it?
Yeah, let's try it.
Let's make a global table.
Let's make a global table. Let's try it. Okay. So here I have my AWS console. I went into the DynamoDB service and I'm looking at all the tables I have. And I'm currently in the Oregon region, US West 2. So I have this table here, customer contracts. And I can click on the global tables tab, looking at the table, and it doesn't have any other replicas, meaning it's not a global table yet, but it does have some data in there. I guess we could look at that. Okay. So it does have data, and to prove Jeff's point, we can come and go ahead and make it a global table. So I'm going to click Create Replica. Now, Jason, where should we make the replica?
Ireland.
Ireland? Okay.
Somewhere far. I want to make it a challenge for you.
Yes. Okay. EU West 1.
California too quick.
Too quick. Great replica. So just as easy as that. You pick the region, you press the button, and it's going to take a couple of minutes to it does a backup. It moves your data across the other region. It does a restore, and once the restore is done, it also synchronizes, so your data will be up to date. Once the table comes back to status active, we know that it's ready. But yeah, it's as simple as that.
And the table I started with is live during this whole time period as well, right?
That's right. Yeah, the table is live, so we can still look at items, so it doesn't take any downtime, which is nice.
Yeah. So no interruption. That's a very Dynamo thing to assume that you on 24/7, never interrupted. So it's without bringing down, you can make the new table, then the new table's available. And then I could potentially remove the original one. And now I'm only in Ireland. I was in Oregon. I'm now in Ireland. Just move it like that, right?
Yeah, definitely. You could do that. It could be a migration strategy. If you just rather have your stack run in a different region, just make it a global table, take off the original region.
Mm-hmm. Gotcha. All right, so when we come back, are we going to have a new global table? It takes a few minutes because it has to do a backup, copy, things like that, right?
That's right. If you do an empty table, it takes a few seconds. If you do a table that's got some data in it, it's going to take a few minutes.
Okay. All right, we'll come back and you can prove it. Let's go. Right. Let's go back to putting Jeff in the hot seat. When I'm doing this kind of thing and I'm doing it right, what kind of latency should I expect in crossing the data?
Yeah, so of course, the amount of time it takes to replicate data from one region to another is influenced by how far apart those regions are. It's obviously going to take a little more time to replicate data, say, from the East Coast of the United States to Dublin or to Japan. But generally speaking, especially within a continent, we see data replicate within 1 to 2 seconds is typically what we'll expect to experience.
Is there a way I can see what I'm getting? Some sort of metric?
Yeah, so we do have a replication latency metric that we publish in CloudWatch, which is, as you know, AWS's monitoring and management service. You can build dashboards for your latency and keep track of what's going on, set alarms, things like that. Yep.
So it sort of tells me what am I getting right now, and I could have an alarm if that said, "Oh, it's rising." I could be like, "Oh, what's going on? There's something interrupting my flow."
Absolutely. Right? Yep.
All right. Now, I think the big question everyone's probably thinking at this point, and by the way, if you have questions, write them in. We've got the chat room open. We'll answer them. This is live. Is how do you handle conflicts? If I have multiple regions and I write to the same item at the same time with different values, what do you do?
So global tables replication is eventually consistent, and it is conflicts are resolved using what's called a last writer wins algorithm. And what that means is that if you were to make changes to the same item in multiple regions at the same time in a global table, we're always going to converge the global table to whatever the last change was that was made to that item. That's the last writer wins approach. And so what that means is that, if you have a lot of changes happening to an item at the same time in 2 or 3 regions at the same time, it is possible that for instance, one of the writes can appear to be in the past because a newer write has appeared and overwritten what that value would be, and that's what we end up converging to. And so last writer wins is the easy way to think about it.
All right, so it's that way everybody settles on the right value as the final value. That's what we mean by eventually consistent. All right.
Now we do have some customers who want to have certain parts of their workload that want to be replicated, but maybe can't tolerate eventual consistency. And they simply approach that by making sure that they only make changes to the set of data in one region, right? And so that's a way that you can be sure that your other regions aren't contending. That's not necessary, of course, but it is one approach to dealing with managing your consistency conflict resolution, for sure.
Yeah, you could do what a relational database tends to do, of write here and just have the other one be a... I feel like we didn't talk enough about the reasons you do this, because I think this relates. And maybe we should cover that a little bit. Like, what are the reasons that you see people deploy global tables?
Yeah, so the first one is about performance. So one of the nice things about replicating your data to multiple regions is that you can get your data closer to where your customers are if you're operating internationally, which of course many of our customers are these days. And so, if you can think about, well, perhaps I have some customers that I want to keep data for and make changes to and read that data from in the East Coast of the US, and then I have some in the EU. Well, I really want to locate that data closer to those customers, so I don't have to go across the ocean every time I want to read an update for that customer. And so if you create a global table and you replicate your data, maybe, a copy in the EU and a copy in the East Coast of the US, then you can always go to where the data is closest and get much lower read and write latencies for that customer data. And so an example of where we've seen this at scale with a customer would be Zoom, right? So during the COVID pandemic, when all of us were trying to figure out how we were going to sort of switch from going into the office to working from home, and everybody needed a way to communicate, Zoom saw an enormous increase in demand from their customer base, obviously, because we all wanted to collaborate and work together remotely. And so what they were able to do was to use global tables to replicate their user data across multiple regions to get that data closer to those users. And so, when those users wanted to join conferences or update some metadata about who was on a call or what they were doing, they were able to do that in the region that was closest to where the users were in the conference, and that helped them achieve the scale and do what they needed to let all of us work together.
I think a lot of times we think about global tables as a way to do a disaster recovery planning.
Mm-hmm.
That I want to have a second copy of the data, but the lower latency reads are pretty straightforward, right? Like read from the region that you're nearest to.
Yep.
You can also do writes. Let's not get into it yet. I think it's a deep subject. Sure. But we want to figure out, like, how do I route those writes exactly? I understand we have a couple of questions. Someone's asking about global table versions in 2017 and 2019. I know, Jeff, you have opinions.
I do. So we launched the original version of global tables in 2017. And in the couple of years after we launched the feature, we got customer feedback that let us know that we could do a better job in some areas with global tables. And so we made a lot of improvements. And in 2019, we launched what is now the current version of global tables. And that is the right version for all of our customers to use. The 2019 current version of global tables it's much more efficient. It is almost always lower cost for customer workloads. And it is the basis on which all of our new features for GT going forward are going to be built. And so that's the right version for customers to use. And so if you're using global tables version 2017 today, I encourage you to look into upgrading to 2019. That doesn't mean that 2017 is going away anytime soon. We're going to support it for the foreseeable future. There's no time pressure on customers where they have to worry about this, but in almost every case, the benefits for customers are very real, and they're happy that they made the change. And it's very easy. It's an online process to upgrade where you can continue to use your database while it happens. Just a couple of clicks in the console to change a table. We have some pretty extensive documentation that talks about some differences in functionality in terms of how the customer experience is between the two. They're relatively minor, but of course we want to be thorough. And so I encourage you to go take a look at those docs and understand the implications before you do it. But yeah, please use 2019. That's the right version.
Yeah, it's push button simple. I think it's only console driven though. And
that's right.
Something you'll want to be aware of is if you're doing cloud formation or whatnot, you have to be intelligent about switching from one to another one. And so the docs explain how to do that. But as far as the actual migration goes, there's no downtime. You never have to interrupt or write, which is pretty wild. It does it all in the background. Push a console button. And at one point it's 2017 and then it's 2019. Takes a little bit of time. And you got on both sides and you save money. Yeah, I did the math with you once on the cost savings. Basically, you consume fewer replicated write units when you're doing 2019 than when you're doing 2017.
Yeah, that's right.
We call it GTV 1v2.
We improved the efficiency, so we have to do fewer writes for the same amount of replication in the newer version, and that means lower costs for customers.
Yep, which is a nice thing. Rob, I feel like we need to see another demo. I would like to see a demo of conflicts. I want to see.
Yeah. Okay. Yeah, we're talking about a lot of stuff here. We have a couple of demos to show. So what we have here is we have a workshop, DynamoDB version day, and in that you can do this workshop called multi-region. And we build a stack out. This is to set the stage for the demo. We build two stacks out, one in each region. They're identical stacks. And the colored building blocks you see here there's three of them. There's DynamoDB in blue at the bottom. That's our database level. There's the middle tier, which is a Lambda function running Python code. And there's also this red pink thing called the API gateway. And this is like an API service that you can create that has authentication built in. In this case, it's wide open and public. So, a browser or any kind of client web app can find the URL and make read and write calls against it.
It's a little cookie there, huh?
The cookie architecture, right? Yeah. So it's actually got the APIs, the host name, the API for both regions. And so as we'll see later in the demo, it can decide which one might be better to use. If it doesn't hear from API 1, it can just try API 2. It's a very simple failover strategy. But let's give it a try. So the API for the US West region in Oregon, we can add this to this demo page that I have. And we can go ahead and try some read and write functions. So I'm going to, hold on, let's add the API here. Okay, there we go. And now we have USOS 2, we have an API, we have a single item in DynamoDB that's got a partition key of user 100. The sort key is the name of a huge show called Ashland Valley. Think of a streaming service, and the user hasn't really started watching it yet. So their bookmark, how far they got in the show, is 0 seconds. And the latency is shown here on the right. So the first latency you'll see is DynamoDB's latency as measured by the Lambda function in the same region. And that's typically, very often under 10 milliseconds, 5 milliseconds often. The other latency is from my house here in Boston all the way over to Oregon, a bit higher, jumping across the internet. The first thing about DynamoDB is if you make a change, if I bump that bookmark up to 1 and then read the item very quickly, you'll see the 1. Even though it's a default, eventually consistent read, it's almost impossible to get a stale read, which is nice. But we do have strong reads if you do need that. So the thing about the demo is that we need to start showing off the global tables functionality. So let's go ahead and add our second stack, which is in Ireland. There we go. Now we have a different color. We have a stack there, and we can click Get Item. And when the Lambda function is warmed up, we see same kind of typical latency, around 10 milliseconds often between the Lambda function and the Dynamo table.
And 169 is because it's you to the region, I guess to you to Ireland, and 7 milliseconds when it's actually within the region, right?
That's right. Yeah, for me,
2 times there.
So yeah, it's a little bit farther for me to Ireland than it is for me to Oregon on the right. But yeah, at least the DynamoDB read latency is pretty good. Okay, so the first thing we're going to do is we have these buttons here to increment, to do writes. And now this is a special kind of write. This is an increment that we have as a feature of update item in DynamoDB. So I'm going to bump this one up, and then I'm going to read it in the other region and see what I see. So I made it go from 1 to 2. It was fast, right? And then in less than a second later, it was already in the other Ireland region. So I'm trying to demo this for you guys to show you that I can be faster than global tables, but I'm not always faster.
Click faster.
Okay, scene.
You didn't do it.
3 to 3. All right, let's try these buttons quicker. There we go. Okay,
You did it. All right.
I did it. 3 to 4. So 0.6 seconds later, it wasn't aware of that, but 1 second later, it had the value. So that's the typical latency. As Jeff said, replication latency in CloudWatch will show you the average of that number as we measure it all the time on your behalf.
Right. That was zippy. And that's Oregon to Ireland. We kind of intentionally chose distant regions to increase the latency. If we'd done US East 1 and 2, those are really close together, and you get much lower latency there because the speed of light or number of routings that have to happen, right?
Yeah, exactly. Yeah, going from Virginia to Ohio, that's a common set of 2 regions for really low latency.
What if you do like increment on a lot on one and then decrement on the other one? Could I lose one of the?
Yeah, well, there's the conflict. Let's try the conflict now. So we have the current value of 4 on both regions. I'm going to bump it up to 5 here, and then I'm going to decrement it here. And depending on if the second region knows about the first write, if I'm slow, then it will take it from 5 back down to 4. But if I'm fast, it'll go from 4 down to 3 as if it never heard about the first update. So let's give it a try.
So you weren't fast enough. You went to 5, it went to 4.
Yeah. So keep in mind, this is from Oregon to Ireland. That's it's pretty far. What was that? 4,500 miles. All right, let's try it
faster.
Faster. There we go.
Hey, you were fast enough. I
Okay,
celebrated the fact that we lost our plus. But yeah.
So 4 to 5, half a second later, it went from 4 down to 3. Didn't hear about the 5. And these two here would have been the conflict, right? So the system will compare the two timestamps of those, realize that the one in EUS was later, and that should be the final value everywhere. So this value from 4 to 5, it effectively was like pruned from the timeline, and then the value of 3 became the winning value, and that's the same everywhere now, as you can see.
Makes sense. All right. Did the table replicate, Rob? What I did before?
Yeah, let's check.
Oh, I see creating there. Let's hit the hey,
active. Okay, there we go.
All right.
So it's in Ireland. We saw that it had data in the US West 2 region, and if we explore table items, there's the same data. So yeah, it did the backup, did the restore, it replicated. If I had made changes, it would have been just like the demo I showed. It would take a second and it would replicate everywhere.
Right.
Pretty slick.
Right. The one that you were doing the increment, that was a different table than this one. That was a pre-existing global table. You're doing the increment decrement. This is a new table.
That's right.
Global table. It went from normal table to global table.
Yeah, let's take a look at that one. I mean, it is a global table. Now it's got 3 total regions, but you can.
Oh, we were saying Ireland, but it's actually it's not in Ireland. Look at that. You're in Asia Pacific, Singapore. You're doing Oregon to Singapore.
No, I switched my region into Ireland. So, but let's come back to the Oregon point of view. Yeah, there we go. So it's got 3 regions, and we could add another one the same way anytime we want, or we could take one away. So very flexible. Yep.
Oh, we had Ireland, Singapore. All right. So that was synchronizing Oregon, Singapore, Ireland, all. And we were looking at 2 points, the Oregon and Ireland one for the increment and decrement. Gotcha.
That's right.
All right.
Yep.
Thanks. I'll come back to you for another demo.
Okay, let's change that one. Yep. Very good.
Jeff, did you want to talk more about we got another one. Is there a single point of failure risks?
Well, let me talk about that a little bit. So not just global tables, but DynamoDB is architected throughout to eliminate single point of failure risks, right? And so even when we're not using multiple regions, if you're familiar, under the hood, Dynamo keeps 3 copies of your data, and the system is engineered to handle interruptions under the hood. So your database keeps working should hardware failures or network interruptions happen. You know, our CTO, Werner, always says everything fails all the time. Dynamo takes that to heart, and we designed for that. So global tables takes that same approach and broadens it to multiple AWS regions. From the customer engineering architecture perspective, right, they don't have to think about using global tables as worrying about a single point of failure. As we talked about, there's no concept of database failover in global tables, right? It's multi-active. You can write to multiple AWS and read from multiple AWS regions in your global table at the same time. And so what that lets you do is to build an application architecture that can have redundant copies in multiple regions so you can handle failures and continue to operate your workloads.
Yeah, if a disk fails, no big deal. If a node fails, no big deal. If an availability zone fails, no big deal, because the data is kept in 3 places, so you still have 2 availability zones. Dynamo always puts it in 3. And now, if a region should be the source of problems, no big deal.
That's right. And
tables, right?
That's another major reason that customers choose to use global tables, is because they want to protect themselves against an event that could affect an entire AWS region. And so high availability approaches are a pretty common use case for global tables. We see customers adopt 2 major approaches. The first is where they'll use one region as kind of where they do most of their work, right? And they'll let global tables replicate their data to another region, and they'll have some sort of contingency plan to say, hey, if for some reason I'm getting more errors than I want, or my latency goes way higher than I'm expecting in my primary region, then I'll go ahead and shift my workloads over to my secondary target region. Keeping in mind, primary and secondary, not global tables concepts. I'm talking about from a customer architecture perspective here. But more and more, we're seeing customers intentionally operate at least part of their workload in multiple AWS regions continuously. And I think that's in part because customer requirements for their recovery point objectives and the recovery time objectives continue to get lower. Everybody wants to be more resilient to failure. And so If you're already operating in multiple regions, then all you really have to do is shift where your workload traffic is happening, as opposed to going and building a new stack before you can get your workload up and running again. And so that's another reason why Global Tables multi-active architecture is so useful. Customers just don't have to think about it. They just use the region that makes the most sense at the time for what they need to do.
Is there a different SLA if you have global tables than if you don't?
Yeah, so our DynamoDB SLA target is 4 nines for a single AWS region. And then if you deploy a global table into 2 or more regions, that goes up to 5 nines as their SLA target.
Yep. It's 5 nines without operational burden on the customer, which
that's right.
I've worked on 5 nines systems. It's not easy to do if you're self-hosting. It's pretty amazing. You hit a button to add global tables, you get a 5.9 SLA out of it. We were talking before about favorite customers. Rob, do you have a favorite kind of use case, favorite customer story about global tables? What do you see?
Yeah, I think, having the warm standby is nice. Having, bookmarks available, like for streaming services, is pretty nice. You could travel to another continent, pick up your show, watch it, not have any delays.
Watch your show?
Well, you could like fire up your episode and, not wait for the bookmark to come from halfway around the world. So,
gotcha.
Yeah.
So when you're talking shows, you're talking about like streaming services that would use global tables, and into the global table would be all the knowledge about me, what shows I'm watching, my bookmarks, my ratings, that kind of stuff.
Yeah.
Now, do they do that for lower latency reads, lower latency writes, high availability, or all of the above?
Yeah, I think the main high availability is probably the main reason. Just having another copy means you don't have to worry as much about daily backups. Your data is in 6 locations with 2 region global table. But the secondary benefit would be the low latency reads. Yeah, putting your data close to users, DynamoDB is already almost as fast as a memory cache. Right, so you're going to get reads in 5 to 10 milliseconds, like we saw in the demo. So we shouldn't be the long pole in the tent for a streaming service to do lookups like that to start your experience.
Yeah, I've heard it called a push cache, where you write in one region and basically you push to the various regions a copy. Maybe you also use Global Accelerator, CloudFront, or whatnot, but you've at least moved the live data around in an active way. Can we get we
also have bank customers, right? We have Capital One. Jeff, do you work with them?
Yeah, absolutely. So, one of the interesting things about the high availability that GT delivers is that a lot of industries that are heavily regulated have requirements about keeping copies of their data that are a certain distance apart. The financial industry is a great example of that. And so Capital One's a customer who has talked about how they've used global tables to meet the regulatory requirements for high availability by keeping multiple copies of their data in different regions. And so we see that not just in financial, but in travel, as you said, streaming and media. Customers in a surprising number of industries have to think really carefully about their regulators and how they're meeting those requirements, and global tables helps there for sure.
I tried that on my teenager. Like, we support Capital One with the regulatory requirements, and he was not impressed at all.
Yeah.
That's even worse.
I had better luck with streaming services.
Come on, Jeff.
Streaming services and video games were a little bit more appealing to the teenage mind. Rob, can we get an example of what it looks like for a streaming service to do global tables? So far we've done very low level, clicky up and down, but put it into like an application experience.
Yeah, let's do that. Let's do another demo. So back to our stack analogy. In this case, because we have 2 identical stacks as a best practice, the application and the routing and the failover, is going to happen at the top level. That's why we have the 2 APIs in memory as cookies. And if we just don't hear back from the stack, if our read and write requests go ignored, it doesn't really matter what's broken, but we can think of the whole stack as broken. So in this case, it could be the Dynamo table. It has problems, but it could be any part of the stack. So for this demo, what I'm going to do is I'm going to take the Lambda function and pause it. And so while you're watching a show, it's trying to write a bookmark every second to see how far you got. If that write fails for more than 15 seconds, as you'll see in the demo, that's going to cause the app to say, hey, you know what, this isn't working anymore. Let's try API 2 and do our writes over there. So it can dynamically switch. So to set the stage for that, let's go ahead and come back to our demo here. We'll click on this Global Flicks sort of fake video streaming service that we have. And we can watch a show. What should we watch? How about this one?
I like the name Tears of Steel. That is funny. Oh, I even got sound here.
You get some sound. I'll turn the sound down. But what we have is we have the book. We have this ability to toggle on the right here. So because of the two regions, Ireland and US West 2, we can make the bookmark point there at any time. We're also looking at those. We're doing read requests.
Client controlled. Client's deciding I'm going to talk to US West 2. It's reading and writing from there. And it's basically tracking the bookmark. So as the movie plays, it says, I'm here, I'm here, I'm here. So if you stop anything, you always remember where you were. And I love it when they do this. Sometimes I notice it's about every 10 seconds they do it. So I'm like, hey, I've seen this before. And I've seen the last 5 seconds. But they're probably doing that so they don't write to, Dynamo every second, but they do every 10 seconds.
For guys like us, Jason, right? If you come back a week later, you might just want 10 seconds to remember what was happening in the show.
That's true. Nice. So the client's picking where to write. It's talking to US West 2, but it's reading from both of them. I see there because it's looking at EU West 1 Ireland and saying this is what it sees, and we see that it's always a second late, which is exactly what you'd expect with synchronizing. Just what Jeff said, where it tends to be around 1 to 2 seconds, and we've seen it faster than that.
All right. Yeah. So should we simulate a failure? Let's add a little chaos to this demo. I'm going to come back here. I'm going to go to Lambda functions. I'm going to find a Lambda function that powers this. And we'll go ahead and pause that.
I see a white screen.
Yeah, what's going on? Maybe in my browsers. Let's just pause
because it's a live demo.
It's a live demo. Let's shoot. Okay.
Logged out or something. Yeah.
We'll come back in.
To federate in and authenticate. It always knows to de-authenticate in the middle of a demo. I think one of the things
is real, right? We're not doing anything. There's no magic tricks here. Right. This is a real live demo.
If this were a recorded demo, we really put the bad version in. I think while you're figuring this out, the thing that we're saying that's important here is that the failure doesn't have to be at the DynamoDB level. Dynamo is very robust, but perhaps there's an issue with the Lambda. Maybe it's that the Lambda system, but maybe you just put bad Lambda code. Maybe you're getting a Lambda limit, whatever it is that is causing some sort of increased latency, bad metrics is going to be the thing that says, you know what, this region's not doing great for me. Maybe I'll go to another region. It could be between the region and the video player in this case, that the video player just can't talk to the West Coast of the US and could talk to the East Coast.
Yeah, that's right.
So I think that's more. You're trying to simulate a failure, and Rob, you got a failure.
I think we're back in business. Maybe it was my browser. I have a different browser here that seems to have loaded the console. So let's give this a try.
Okay. When you said simulate a failure, I didn't mean that failure.
Yeah, that's right. It's relatable, right? When you struggle, not everything goes according to plan. Oh yeah, here we go. So, it did load. All right, be patient. Yeah.
What's going on with you?
Did it? Gosh darn it. Okay, here we go. All right.
There it goes.
Now, this is the Lambda function. Let's go ahead and come back to our demo. Let's watch a different movie, shall we?
I want to see Tears of Steel.
Tears of Steel, yeah.
Isn't that great, Manny?
It looks intense.
Of course.
It's probably the video player stealing all the memory on my laptop, right?
Yeah, I think you got some sort of laptop level issue because everything's just sluggish on you right now.
Let's try coffee.
Very.
Will work. Okay, so we have that. Let's go back to.
So you're playing the movie. You're talking to US West 2.
Yep.
You go to
we look here. Here, this is what's doing the region rights to DynamoDB. So we can throttle this. In this case, throttle. Let's turn the line down all the way. We can throttle it. We can come to here, and Throttle in DynamoDB means like a warning, but in the serverless Lambda world, it means like a pause. I'm going to throttle the function. Now it's not going to work. Now if we come back to the demo, right away, unable to write US West 2. It knew that it should started failing. It's going to give it 15 seconds, keep trying, and then if not, it's going to give up and try its other region.
Right. The font is small, but it says unable. Oh, it went away already. Because did you do that, or did it do that to change to US 2? It did it.
It said that, yeah, I was going to have to wait 15 seconds. And if it still doesn't work, that's enough time. You don't want to maybe fail over on one single error because it could be a intermittent thing. But if you get no luck for 15 seconds, maybe this region's really gone and you want to just try the other region.
All right, click US West 2. Force it back. I want to see it do it again. Click
all right, let's force it back. See, unable to write to US West 2, failing over to alternate region.
In 15 seconds, if available, error reading from US West 2. So if we wait 15 seconds, during these 15 seconds, that would be a good time for me to plug a survey. We're putting into the chat as the survey. The first 50 people who fill it out get $20 in AWS credits. So you can see that link in the chat. Feel free to ask your own questions in the chat as well while we watch the error happen. And so what happened here is US West 2 failed. It took 15 seconds, and it decided on its own, client's choice, to go to EU West 1. And life goes on. The end user watching the video would never nor care about this failure, right? We only know because you're popping up the red text underneath. But so long as the client can talk to one of the endpoints, it gets the latest copy of the data and it can read and write data. And nothing had to happen on the server side to say, oh, I'm in failover mode. And other clients might not even be having an issue with that region. Maybe it's just your lucky client, because we did see that your browser is having a rough hair day.
That's right. Yeah. So yeah, it can make that decision on its own. The key thing about doing this routing decision, it may need to be something more robust. There's other sort of networking tricks we can do apart from this 2-cookie approach, but don't make any routing algorithm in the region, right? If you imagine the whole region's suddenly gone, then whatever you have that was doing the routing decisions is also going to be gone. So it's probably like something like you mentioned, a global accelerator or DNS global, to pick a different IP address or, different stack endpoint.
Jeff, do we have a global endpoint where I can just talk to one endpoint and it does its choice?
So we do not have a global endpoint for global tables, and that's very intentional. So certainly that's something that I've talked to a lot of customers about, where they'd say, hey, I'd kind of like it if I could just talk to one place and you sort of figured out which global table replica to send me to get the data. The thing about that is it gets a little more complicated when you start to consider then that the latency profiles you're going to see may vary, right? Depending on what we decide on the back end. And as we said, that sometimes customers want to make sure that they know what they're talking to, even though we're replicating the data everywhere globally. And so where we kind of end up with those conversations is that since customers have control in terms of what endpoint they can talk to, they end up preferring, I think, most of the time to make decisions on their behalf about which global table replica to communicate with in order to process their traffic, which is, of course, pretty easy. We have the SDKs that are obviously very straightforward and easy to use in terms of making sure that you can have connections if you want to multiple replicas and make decisions based on that.
Do you have advice, either of you, on the best way from the client to decide what to do? The example we just saw was client's choice, right? Client-directed routing. And I will say at a tech level, that worked pretty well because every one of our writes was essentially idempotent. We were like, they're at this time, they're at this time. The last writer wins works perfectly for that, because if I write here and my that's not working, I'll write over here. Unlike the increment decrement, there was no sort of conflict where we would overwrite in the event of double writing the same item in two regions. And same with like a customer updating their address. My address is this, that's not working. My address is this. Last writer wins is perfect for remembering their latest address. It's more like accounting. We have to be really careful. So if I'm doing this, what choices do I have besides the client chooses? Can I do like Route 53 and have DNS I hit an endpoint and I don't know where it goes?
That's right. Yeah, there's features within Route 53 and Global Accelerator to measure the performance of the the request that you're making, and there's also features to measure the closest region, right? Depending on the IP address, the country that you're detected in, it can pick a region that's appropriate for where you're at.
So in that case, the client doesn't know necessarily. They go to well-known name, and it doesn't have to send all traffic to one region either. It could say, well, you're kind of close here and you're kind of close there. And then I think the difference from my experience, if possible, I always do kind of like client driven because I can figure out my latency, because, your network route might be different than what Route 53 sees. Like maybe you're closer, you're in Boston probably today, right? So maybe you're closer to Oregon, but routing wise, you're closer to Ireland, and it just was able to say what it sees right this moment.
Yeah, there you go. When you fire up the app, you could check out both APIs, maybe do 5 requests to each, see which one is faster, and then make that the preferred way.
Right. And change its mind just like how the app did change its mind in the event of, I don't know, it used to be good, but it's not good right now. I'll go to the other one. But otherwise, you could do Route 53, which says just go to a well-known name, and it decides what you do. It could do weighted. You can try to do latency or geographic. You can do global accelerator, where you more quickly get on the AWS backbone to do this stuff. So a lot of choices there. And I think we should put in the show notes, I actually wrote up a prescriptive guidance about this specific deep stuff. So if we could put that out there into the chat for people who want to go and read the deep version of this, that'd probably be a good idea. What were you saying, Rob?
Yeah, one pattern I've had, customers, they'll come to meetings and they say, what happens if a region suddenly disappears? And I'm that's a really bad day. I think what's probably more likely to happen is region just has a brownout or a degradation, as we call it. Right? It just gets slower. Maybe error rates are higher than normal. The latency is 20% worse than it usually is. That's probably more likely to happen in the next few years. And so I would put together a run book, kind of like when a pilot flying a plane. If the oil pressure drops below a certain threshold, they don't panic. They just open up their run book. They turn to the page. They follow the checklist. They do some diagnostics perhaps. And, they might have to land early or not, right? But they can, they have a plan to solve the problem. And it's the same thing with, a region having, a bad day or a brownout. That's a good thing to think about in advance so you can decide, if you're going to manually switch over or if you're going to write some sort of an algorithm to do that switch over based on, strong signals that it's the region not working for your requirements.
Yeah, I think that's great. I think people think global tables is for if DynamoDB in one region has issues, but it is really, if anything, in that region has issues, you might decide that you'd rather have more traffic or all your traffic go somewhere else, and you use global tables as a way to make sure that your state is available in that other region. And so you want to be smart when you're doing these global deployments. Ideally, you don't even want the same roles in all regions in case you mess up on the deployment of a new IAM role. Like, oh my gosh, I broke west. Let's go east. And I'll do the damage, but hit the button. We're going east because maybe I did a bad deployment. I can't believe I throttled that Lambda. Or you just don't know what it is. I think usually the moment of things are going weird, you don't know what it is. And you say, I'm going to figure it out later. But right now I'm going to keep my customers happy because I've got a perfectly good. I think of like 2 cars in the parking garage. I tried to turn on my car. I don't know why it didn't work. I have another car. I got to work. Later on, I'll figure out that, oh yeah, I used the wrong key. Whatever it is. That was the issue.
That's right.
Someone's got a question about API 1, API 2. If we can get it prompted up there.
Yeah, we can
talk about API 1 and 2.
Let's see.
Couldn't it go out of sync if it switches the database, especially if it is client-based? Oh, I like that this person's paying attention. Imagine the client has a problem to connect to API 1, then uses API 2, but at the same time, other clients still use API 1. Sounds like a database nightmare.
I think both APIs in theory are still working. If API 1 just doesn't respond for you, it might be better for somebody in a different region or a different, it's really up to the client to decide. In this particular demo, remember we did update item and we did a increment, and that's kind of the riskiest type of write to do because, if you do that twice or if you fail to do that, your account, in the case of a movie bookmark, it's not that critical, right? But a safer thing would be to do something that is idempotent. If you're setting the balance on a checking account, for example, and you calculate the new balance is $200, you can just say update the item and set it to exactly 200. And if somebody on another region does the same thing and they set it to 200, like those will never conflict. So they'll be the same value. But anytime you're doing an increment like this, where you want to make sure that they 100% succeed, then you run into a little bit of risk that if an increment is lost or API doesn't respond, then they could you have fewer increments or more increments than you expected.
I'd say it's a deep topic, and you want to understand. As long as you're writing to different items, no issues. The question arises: what if I write to the same item at the same time in two different regions? In which case, you have to think what if, and you want to think that through. With the movie case, I'm writing a bookmark. It's all right. I mean, if you're watching this, you under your account are watching the same movie. And on two screens, they're going to conflict. And what do you expect? Even if you're writing to one region, I'm at 1 minute, I'm at 10 minutes, I'm at 2 minutes, I'm at 11 minutes. Like that, the last writer is going to win, whichever one was the last one watching. But what's important, I think, with the financial one is a good example, because what I've seen there, someone wanted to do credit card balances. How much is left? How much credit do you have left? Because they had to approve the charge. And they're like, how do I maintain that balance reliably with global tables where I'm going to be decrementing? And I want to make sure that I don't like decrement, and lose one of the decrements, because we simulated that in your demo there. And you know what they did was they had two buckets. They split the amount that they could allocate to the customer into two, and they had the west and the east buckets. When you're decrementing in east, you decrement the east value. When you're in west, you decrement the west value. And that way, they never updated the same item at the same time in two regions, but they still had full resiliency, because if one region was down, they could decrement from this one. They just have to carefully balance once in a while, but most of the time, you're not anywhere near zero. And now one region could be avoided, and you just decrement from this one, you decrement from that one. And periodically, you kind of do a pause on decrements, move some balance from one to the other. Okay, resume decrementability. And I thought that was a great way to handle it. And this stuff, it's deep. That prescriptive guidance link that I want to go out is 25 pages that discusses largely this kind of stuff, because it's a really easy model. Last writer wins. But then, what does that mean? And how do I route is kind of interesting stuff. If other people have questions, feel free to keep asking. This stuff's good. I want to understand how it works internally, ideally. Jeff, can you explain, if it's done in 1 to 2 seconds, what's it doing?
Yeah, so there is a feature for DynamoDB called Streams, and Streams is an ordered change log of updates that happen to a table in DynamoDB. These are regional, so every table in a region can have a stream associated with it. When you go and you create a new replica for a regional DynamoDB table, thus making it a global table because we have two replicas in two regions, we do a couple of things in the background. The first thing we do is that if Streams is not already enabled for that table, we turn it on, because that's the change source that we use to replicate the changes. Then we take a copy of the data that exists in what I'll call the source table, and we restore that to where the new replica region is going to be, which is, we talked about that a little bit before, taking a few minutes depending on, sort of the size of that source table for the new replica. And then at the same time, we start reading from that stream the changes that are happening, making sure that we can apply them to the new replica. And when we reach a point where we've restored all the data from the copy and we are caught up with respect to where we're in the change application point, that's where you see that table replica become active, and we're up and running. And then every time you write a change to either the source original table that's now replica or the new replica, it works the same way. We're going to see that change appear in that replica stream. We have an internal replication process that reads that, and it applies it to a replica in a remote region. And we have one of these for basically every region that's in a global table. So it's parallelized, which is part of the reason that we get that higher performance. And it's easiest to think about this as sort of like a full mesh parallel replication system. So if I have 6 replicas, they're all constantly replicating to each other at the same time, so we can achieve fairly low latency replication regardless of where you're doing your writes.
Yeah, so, and if you haven't used Streams, you should, right? Because it lets you watch for changes, and you can do a variety of things. And we built on that to copy the data over with enough state management. I think that it was probably easy to get a mostly solution, but to make it bulletproof probably was a lot of engineering work. I wasn't there for it. I wasn't around in 2017. And then a last question for you, Jeff, is what's the pricing model of global tables? How does it work when I go from, what did Rob just incur on himself when he went from 1 to 2?
Sure. So the primary difference between pricing for a regional DynamoDB table and a global table is in how we bill you for the write traffic. So Of course, Dynamo has a several different pricing dimensions for storage and for reads and for writes and so forth. If you only have a single regional table, we bill those writes in one particular billing unit. The unit depends on whether you're using on demand, which is our automatically scaling with the traffic rate that you're doing, or whether you're using provision capacity, which is where we kind of give you a knob that you can turn depending on how much throughput you need to achieve with your table. When you change to a global table by adding a replica, the important thing that changes from a billing perspective is that we change from charging the regional write units to now a replicated write unit. And again, there's two depending on whether it's on demand or provisioned. That's going to be billed for every region that has a replica in your global table. So, if you have two regions and you write to region A, you're going to get billed a replicated write unit in region A and a replicated write unit in region B. Pretty much all of the other billing dimensions remain the same for a global table replica. The storage is charged the same. The reads are charged the same. So all of those are going to be familiar and no different than
right
for a regional table.
So I double my storage. So I should expect a storage bill because now I have two copies. So I have double storage, and I double my writes because I write here, right there. That's right. So I double my writes, and my writes are a slightly different unit, a different SKU, as people would say, which is a replicated write instead of a regular write unit.
Correct.
So you do that. But then it goes back, if I remove the remote region, it goes back to a single copy of the data and back to regular writes. Do I need to use CloudWatch to monitor my table's performance and adjust read-write capacity as needed to avoid throttling? No different with global tables, except you want to be you don't want to be aware in the event that you're going to do a failover that you have enough provision, right? Any other things they should consider?
Well, so the answer for that is mostly the same for global tables and DynamoDB, right? As I said before, the easy button is just to use our on-demand mode. We handle it for you. You really don't have to think about it. We adjust your throughput as you need, and you can move on to thinking about other things. Should you choose to use the provision capacity mode, that's those knobs for read and write throughput that I talked about. For global tables specifically, we synchronize the write capacity settings across all of your global table replicas, and that's required. And we do that because we need to make sure that our replication velocity remains constant based on how fast you're writing to one region. If we didn't do this, we could run into a situation where you didn't have enough write capacity in a remote region, and then we couldn't update it fast enough and it would fall behind. But you can have different read capacity settings and on different replicas in different regions. And in fact, we see customers choose to do that sometimes as sort of a cost optimization. If they're using global tables for high availability, they pretty much only use one region. They kind of have that other region just to sort of a backup in case they want to fail over to it. They might turn the read units down in that region because, they're not doing many reads there and don't want to pay for them. But the basic answer is we have on demand, and for provision mode, we have auto scaling, which is required, by the way, if you're using global tables, where you set your upper and lower limits and your utilization target, and will automatically scale for you. So you don't have to manually go watch your usage and change things, but you do need to either use on demand or appropriately set up auto scaling in order to make sure you're not getting throttled when you don't want to be.
Right. Cool. I think we have 1 minute left, and I want to go back to Rob's videos because I think we didn't fully enjoy the fact that Rob put together these Blender videos.
Yeah, there's a bunch of videos. There's some of them are funnier than others. Is there one you want to close with, Jason?
You're avoiding Agent 327, which makes me want to do Agent 327.
Operation Barbershop? All right, let's give it a try. Check the bookmarks. It's going to load. Volumes at full. All right, let's sit back.
Volumes at full.
Enjoy the video. Here it comes.
Love your browser, Rob.
I think it's because we're broadcasting and we're watching video on a laptop. My poor laptop. Yeah, no.
We
All
got
right,
you
everyone. Follow along. All right. Yeah.
Thanks, everybody.
Thanks for coming today.
Tables.
See you next time.
Next week is going to be how the NFL uses vector search, which is really, really interesting stuff. So it'll be next week, same time. Thanks, everybody. Thanks, Jeff. Thanks, Rob.
Thanks. Cheers.
Thank you.
Bye. you.